Hi students, coming to the next application in backtracking, that is the sum of subset. In the previous video I explained about the n-queen problem. Now let us see the sum of subset. So what is the sum of subset problem? Actually this problem, the sum of subset problem, let me write the definition. The problem is to find a subset of a given set. We have to find a problem. The problem is to find a subset of a given set. S is equal to S1, S2 up to Sn of n positive integers whose sum is equal to a given positive integer d. So this is the definition of sum of subsets. So the problem is to find a subset of given set. So for this given set S1 to up to Sn, for this given set we have to find the problems for subsets. Different subsets are there of n positive integers whose sum is equal to given positive integer n. So whatever the subset that we are finding out from this set, that subset should be equal to the sum of the equal to the given integer, that is a d. That should be equal to that sum. So whatever the in this set we have to find out some integers. Those integers should be equal to this integer, sum of this integer. So sum is equal to a given positive integer, that is a d. So that is a condition for sum of subsets. So just we have to take some sets in this set, that we have to solve those subset, and finally we have to find out this integer. So here the observation is, it is convenient to sort the set elements in increasing order. So let us take whatever the problem you are given. So that in that problem we have to make arrange the elements that should be in increasing order. That is S1 is less than or equal to S2 is less than or equal to up to S less than or equal to Sm. That should be in increasing order, and each set of solutions don't need to be necessarily a fixed size. And one more condition is, whatever you are finding out a set of solutions for the given problem, there is no need to be necessary that should be a fixed size. Now let us take one example for the sum of subset. Let me take the example. So here is an example for finding out the sum of subsets. Let us take for set S is equal to the set consisting of 4 elements 1, 3, 4, 5. And in this set we have to select a subset. So that subset should be equal to that number. The integer number is 8. The total should be 8. Okay. So from this set, what is the total? That should be 8. What are the sets that subsets that consist of the total is 8. And one thing, the number should be in increasing order. Suppose if I take 1, 3, 4, what is the total? 1 plus 3, 4. 4 plus 4, 8. Okay, I got the solution. I got the integer. So this is solution 1. So is there any subsets that the result is equal to 8? 3, 5. So the solution, the answer is 8. Okay, this is another solution. So from the given set, there is more. I got 2 possible solutions. So number of I'm having 2 possible solutions for the given set. So this is a subset, sum of subsets we call it is. So let me explain this problem by using the state space tree. Let me draw the state space tree. How we are going to calculate this problem by using state space tree. So before starting the state space tree, there are no elements are inserted. So if no elements are inserted, it should be start with 0. Okay, so the starting node should be 0, because if there are no elements in a tree, first start with 0. So the first element that should be inserted is 1. So what are the subset of these zeros? So they should be with 1 with 1 and without 1. So without 1 means just copy the 0. Left side just right side just copy the 0 and right side just add the first element, that is the 1. So now next coming to that. So the next element is 3. So what is the solution with 3? Means here x is equal to 1, x is equal to 3. So with the 3 plus 1 you will get 4. The subsets for this one is with 3 and without 3. Without 3 means just copy 1. Just copy 1 without 3. Means x is equal to 3, x is not equal to 3. That's it. So again, next coming to this, next element is 4. So you have to add 4. X is equal to 4. Means with 4. 4 plus 4, I'll get 8 as an answer. So 8, which is the element which is there, I have to get. So this is a solution. The first solution I got. So with 4 and without 4. Okay. And for this, with 4. Okay. 4 plus 1, 5. Without 4, just copy this element 1. Okay. So right side just copy whatever the element that is there in the tree, that root node consisting of, that node consisting of. Means this is with node and without node. The subset consisting of with and without. With element and without element, those two elements will be present in that set, the 5 one. And now coming to here, so this is with 3 we are calculating. So with the 3, 0 plus 3, 3. Without 3, just copy 0. So this is x is equal to 4. With 4, 4 plus 3, 7. Without 4, just copy whatever the element that is there. And here, with 4, just 0 plus 4, 4. Without 4, just copy 0. Okay. So up to 4 elements are over. Now I have to add 5. The last element in the set is 5. So here already I got the solution. So no need to add elements to this leaf node. Okay. Now next coming to this 4. So if I add 5 to this element, 4 plus 5 is greater than 8. So just skip this node. Now coming to here. So if I add 5 here, 5 plus 5 is greater than 8. So just skip this node. Now coming to here. Now x is equal to 5. 5 plus 1, I'll get 6. And right side just copy that 1. 7. 5 plus 7 is greater than 8. So just skip this node. Now coming to this. 5 plus 3, 8. I got the solution. 8. Okay. And the right side is just copy that element. With 5, without 5. So here x is equal to 5. With 5, without 5. Now coming to the 4. 5 plus 4 is greater than 8. So just ignore this. Okay. So the total, what are the possible solutions that I get? 8 here and 8 here. Okay. So I said I will get 2 possible solutions. So 1 plus 3, 1, 3, 4. 1 plus 3 plus 4 is equal to 8. And here, this is the 3. This 3 and 3 plus 5. Here x is equal to 3. 3 plus 5, you have to write here x is equal to 3. 3 plus 5, 8. Okay. So this is a sum of subset by using we are drawing by using the state space tree. Thank you.